right, so we said neutrophils are the star of the show. So it's really important, even from a testing perspective, to understand, what are neutrophils doing? Why are neutrophils so important? How do they get to the site of inflammation? So the first thing that you want to understand is that, this is really a 4-step process. And I like to think of things in terms of 3s. And, really the big 3 things are going to be, down here. Sometimes you'll see this process with, 5 or 6 or 7 steps. They can, stick an activation step in here somewhere. But the point is, what you see here is what you really have to know. And so the whole idea is, what is this neutrophil migration? It's taking a neutrophil. Okay, so here's our neutrophil. We're taking this neutrophil, and we want this neutrophil to go from the bloodstream, from the vascular lumen, right? This is a big blood vessel here, right? So we want it to go from the bloodstream into the tissues, particularly, specifically to the site of the infection. So we want the pro-inflammatory cells like neutrophils, we want them to start going after this infection. We want them to start phagocytosing this bacteria or whatever this pathogen is. So we got to get them in there. We got to get them to the site of infection. So to get this neutrophil in here, there's a 4-step process that you want to be familiar with. The first step is margination. Let's just say this was the lumen of my blood vessel, right? Maybe this is a really big blood vessel. We don't want the neutrophils out here, right? We want the neutrophils towards the site of infection, towards the endothelium. And so to do that, to get the neutrophils kind of towards the edge here, what we can do is we can increase the vascular permeability. By doing that, by increasing vascular permeability, there's going to be more fluid, essentially, that's going to leak out through these endothelial cells. And so I know it doesn't look very leaky here, but there's going to be more fluid kind of leaking through these. And so by doing that, you're hemoconcentrating. And you'll hear this term a lot when you go in the wards, when you work in the hospital. Hemoconcentration is basically saying if you took volume out of the bloodstream, okay, the cells that would be left in those blood vessels would be more concentrated, right? Because you've taken out some of the fluid, and that's what we're talking about. So the increases in vascular permeability promote hemoconcentration. And if there's more concentration here, it's going to be more likely that there's a neutrophil here as opposed to fluid. It's more likely that you'll have a neutrophil hit these sides of the endothelium. That's the concept. So the increases in vascular permeability with inflammation, part of the reason for that is for hemoconcentration, so we can get an increased propensity for neutrophils to contact their endothelia. Okay, so that's the first concept. That's what margination is. Pretty straightforward. Like I said, the big 3 are down here. So going into that, the next one here is rolling. So what's rolling? Rolling is, eventually this neutrophil might get pretty close to the endothelium here. And what's going to happen is it's got Sial-Lewis X, which is a protein that's on the neutrophil. Now, it's important that I wrote it this way, that you know what's on the neutrophil and what's on the endothelium. You don't have to go into a extremely large amount of detail on this. Just know that this is going to be on the neutrophil. And the neutrophil, as it kind of gets close to the surface of this endothelium, it's going to start to use that Sial-Lewis X to transiently kind of bind to some of the proteins here, particularly the E-selectins and the P-selectins. Okay, and it's also important to remember that the P-selectins are going to come from the Weibel-Palade bodies, and I'll talk more about that to come. But just know that the E-selectins, P-selectins, they're kind of selecting the neutrophil. They're not stopping the neutrophils in their tracks, right? This neutrophil is coming in hot, right? It kind of just touches this and keeps going. Okay, so the neutrophil is not going to stop here because of this binding, but it's going to slow down a little bit. Okay, so this is going to help slow the neutrophil down. Think of this as like a big snowball coming in with a really high velocity. So it's going to kind of start to slow down as it starts to hit these E-selectins using its Sial-Lewis X receptor. Okay, so that's the concept. So that's rolling. Okay, so make sure you're familiar with the proteins in rolling. Now, once we get through this rolling phase, eventually we slow this thing down so much that it links into one of the integrins here, and it just completely stops moving. So we're essentially going to have an adhesion moment, right? A tight adhesion where this thing is not going to move at all. And this tight adhesion is from a combination of 2 things. It's from the ICAM proteins, which stands for intracellular adhesion molecule, intracellular adhesion molecule 1. So kind of, it's like it says, right? It's in the endothelium, it's intracellular, and it's going to cause there to be a tight adhesion, a really tight linkage there to just slow that neutrophil down. It's like, hey, you're not going anywhere now. Okay, so that's ICAM1. If you want some bonus points, that's CD54, not as high yield, but it is important to remember that it is ICAM1 here that's going to be responsible for this tight adhesion step. And the neutrophils typically will have their protein, right? So they're going to have something called LFA1. And LFA1 is the protein that's going to be on the neutrophil. Okay, so we have LFA1, and I'll unhighlight this so you can see it here. So we have LFA1 on the neutrophil, and then we have the ICAM1 coming out of the endothelium, and that's locking this neutrophil in place now. Now also notice there's another receptor here, and I didn't write this one down, but this is going to be the CXCL8R receptor. You might be saying, well, that's a really hard receptor to remember. How am I going to remember that? Well, if you watch the last video, remember the interleukin-8 receptor. Look at, you can see right here. It kind of looks like interleukin-8. If I just put an I right here, we'd have interleukin-8 receptor. Okay, so that's essentially how I remember it, right? So you have L8R. I think of that as interleukin-8 receptor. And that's what it is. So this receptor binds to interleukin-8, right? You can see it binding right here. What does interleukin-8 do again? Interleukin-8 is responsible for chemotaxis, right? Chemotaxis, what are the big three for chemotaxis? We talked about this in the last video. LTB4, right, from the lipooxygenase pathway, interleukin-8, C5a. What's the other thing interleukin-8 does? It causes ongoing inflammation. So if there's a lot of interleukin-8 here binding to this receptor, potentially, it can help stimulate ongoing inflammation and get these neutrophils to go through chemotaxis into the site of infection. So that's what's happening here. Okay, so that's this tight adhesion step, largely driven by intracellular adhesion molecule 1 binding to LFA. Now, there's also a couple different receptors that you might see. You know, there's a lot of variants here. MAC1 tends to be more asked about with macrophages, just like the name implies. MAC1, macrophages. So macrophages have a similar process, but it's really the neutrophil migration that's the heavily tested one. So that's what we're focusing on. Now, the last step here is transmigration. And it's just like it says, right? Trans between, we're migrating between these endothelial cells to get this neutrophil to the site of infection. The whole goal from the beginning was to get this neutrophil in down to the site of infection. And this one's kind of easy to remember because it's the same receptor. It's PCAM1, which essentially stands for platelet endothelial cellular adhesion molecule 1. Now, I know that doesn't directly make complete sense with, you know, a neutrophil migrating through here, and so it's kind of tricky, but I always remember PCAM is kind of like the bigger CAM. ICAM is the first CAM. So ICAM is for like tight adhesion, then PCAM comes after that because it's bigger. Okay, because it's a bigger word. I know it's kind of simple way to remember it, but sometimes simple is good, right? So PCAM1 is going to be responsible for this transmigration. So what this neutrophil is doing is once we lock it in place, we say, hey, you're not going anywhere, that interleukin-8 is going to say, hey, come this way. This is where we want you to be. This is where there's going to be a site of infection. We want that neutrophil here, right? That's what's happening right here. Neutrophil says, hey, I have nowhere to go anyway. I'm locked in. So the neutrophil is then going to transmigrate using this PCAM receptor between endothelial cells to the site of infection. Okay, and that interleukin-8, you can see it all over here, that's basically telling this neutrophil where to go. Interleukin-8, LTB4, right, and then C5a. And another term you'll see kind of synonymously used in this step is this term diapedesis, which is very frequently used kind of when the neutrophil is between these two steps. So you might see diapedesis in there, you know, in terms of terminology, but really the big stuff you have to know is what's already on the slide here.